IPv6 addressing review. In this video, I'm going to talk about the IPv6 addressing. You know that in the CCNA class, we have learned about the IPv6 addressing and some of the other features about the IPv6 addressing. Here, I'm not going to talk about the detail of IPv6 addressing, only I'm going to review the IPv6 addressing because this is necessary for troubleshooting IPv6 networks. About the IPv6, you know that we have many similarities between the IPv6 and also IPv4. For example, you know that in one IPv6 address, okay, we have two parts. The first part is the subnet ID. Let me to show you. The first part is the subnet ID. And after that, the second part is the interface ID, okay? And you know that the subnet ID is same as the network ID in the IPv4, and the interface ID is same as the host ID in the IPv4. About the communication in IPv6 addressing or in TCP IPv6 networks, we have similar rules. For example, for all of the systems that or computers that are residing in one network, we should use the same subnet ID, okay, for all of them, and different interface ID for all of them. For example, in this scenario, as you can see, the PC1, this is the PC1 IP address is 2001 DB8 colon A, okay, double colon 10 /64. You know that for finding the subnet ID, we need to replace the interface ID with 0 because we have 64-bit for subnet ID. We can say the subnet ID of this, for example, IP address is 2001 DB8 colon A again double colon /64. And about the PC2, the IP address of this system is 2001 DB8, then for example A, again colon A, double colon 20 or 2064. Because of that, we can find the subnet ID of this IP address of this PC is 2001 DB8. After that, A colon A double colon /64. Because of that, when you try to send traffic from the PC1 to PC2, we have the similar process. For example, you are typing the ping, the IP address of the PC2. First, the PC1 should compare the bits number equal to its subnet ID, okay, subnet number bits, with the destination IP. Here, for example, we need to compare first 64 bits with the 64 bits of the destination because both of them are same. This means that the PC1 can understand that the destination is residing in its network, and it can send traffic directly to the PC2 after discovering the MAC address of the PC2 with some protocols such as the NDP or Network Discovery Protocol. And also about the communication with the other networks, we need to do again the similar function. This is the intra-network, for example, communication or connection. And here, as you can see, the PC3's IP address is 2001 DB8 colon D, okay, double colon 10 /64, okay, and because of that, we can understand that the subnet ID of this IP address is 2001 DB8 colon D, okay, then colon, for example, 0 double colon /64. This is the subnet ID of the PC3. Because of that, when you are trying to send traffic to the PC3 from PC1 with the ping, for example, 2001 DB8D double colon 20 or double colon 10, okay, this is double colon 10. First, the PC1 should compare its first 64 bits, its first 64 bits of about the IPv6 address of the PC1 with the first 64 bits of the IP address of the PC3. And as you can see here, we don't have any, for example, equal hex set between the hex set 3 and hex set 4. Okay, because of that, the PC1 can understand that the destination is residing in the outside of its network, and this is an inter network connection. And you know that in an inter-network connection, we need to use the routers. Because of that, in PC1, we should configure the correct IP address, such as the IPv4 for about the default gateway. For example, as you can see here, the IP address of the R1 as the default gateway is 2001 db8:A:1, and we should configure this IP address on the PC1 and also PC2. Let me to show you the simple configuration of this scenario only for reviewing. Here we have three computers. This is the computer 1, or this is the PC1. Let me to assign the IPv6 address of this PC. It is so easy. Okay, first we should go to the network connections. This is the network connection in this system. You know that here I'm going to assign the IPv6 address. Because of that, we need to click on the internet protocol IPv6, and then here I'm going to assign the IPv6 address manually. Because of that, use the following IPv6 address. The IPv6 address of this interface is 2001 db8:A:10. Okay, and the subnet prefix length or prefix length is 64, and the default gateway is 2001 db8:A:1. That's it. So easy. Okay, and then close. This is the PC1 configuration. Let me to configure the PC2. This is the PC2, and after that, here again we can go to the network connections. After that, here we should click on the TCP IPv6, not v4, and then use the following IPv6 address: 2001 db8:A:20, for example, :20, and the prefix length is 64, and finally default gateway is 2001 db8:A:1. That's it. And after that, okay, and then for example, close. You know that we should configure the router also. So this is the router. Let me to configure it, and after that we can configure the PC3. This is the router CLI. Very good. And now, okay, let me to wait some second. After that, we can configure the router 1. In router 1, we have two interfaces, ETH00 and ETH01. ETH00 should be configured with the same network ID or subnet ID of the PC1 and PC2. And also interface ETH01 should be configured with the same subnet ID of the IP of PC3. Okay, this is our router, enconf hostname router 1. Okay, about the interface ETH00, the duplex of this interface is full, and then we need to configure IPv6 address 2001 db8:A means :A:1/64, and then no shutdown. After that, interface ETH01, again here duplex is full. Okay, IPv6 address 2001 db8, then D:1/64, and then no shutdown. Also, you know that the routers in IPv6 doesn't forward by default the IPv6 packets or doesn't do the routing. You know, you need to use the IPv6 unicast routing. It is important. If you don't configure IPv6 unicast routing, you cannot use the router for the forwarding traffic from one interface to other interface. Look at here, show IPv6 route in the router. Now can show us that we have two connected interface, 2001 db8:A:1/64 reachable over the ETH00, and 2001 db8:D:/64 reachable from the ETH01. That's it. And the last system, the last computer is the PC3. This is the PC3. And here I'm going to configure the IP address of the PC, the interface of PC3 with IPv6 address here. Okay, again TCP IPv6. This is TCP IPv6. Use the following IPv6 address: 2001, then db8, then D:10. Okay, after that /64, the gateway is 2001 db8:D:1. That's it. and this is the configuration of the PC3. Now, first, let me to show you the addressing of the PC1 and PC2 with this similar command that we saw in the IPv4. The command is ipconfig and also ipconfig/all. Look at here, ipconfig can show us the IPv6 address of the PC1. Look at this is the IPv6 address of this PC1, and also here we can see the for example